All right, so absolute value comes really handy when you're trying to figure out the range at which something can exist in. Well, I guess the variation, something that can exist in when you're given a standard and then a tolerance from that standard. Right, so like average mass of a baseball needs to be about 7 1/8 ounces and has to have a tolerance of 3 7/8 ounces. So my average is represented by that dot right there at 8 7/8, and then the tolerance means it's got to be minus 3 7/8 or plus 3 7/8. Right, so let's see if this was my X and my Y values, right? My X value is going to be the ounce of the baseball, right? And my Y value is going to be the variation from that, all right? So at 3 7/8, right? From that side, right? 8 minus 3 7/8 is 5. My X value would be 5, okay? And then my maximum weight of my baseball is going to be 8 7/8 plus 3 7/8. So that's 11 plus, that's 11 7/8 plus 7/8 is going to be 12 3/4. So 12 3/4 or 14/8. Okay, so that's 12 3/4. All right, so now I am going, actually it's 14/8, 14/8, which makes it 3/4. Yep. So that's going to be 12 3/4 at positive 3 7/8 deviation from that. So this is the deviation from it, is 3 7/8 with, in the middle, 8 7/8, and my deviation is 0. Okay, so I mean, it tells me to add 31/16 for this, but I really don't need to do that. I have my minimum and my maximum, right, and the deviation from that, right? So this whole range is going to be 3 7/8 times 2, which is going to be 9, and then 7/8 times 2 is 14/8, right? So this is going to be 9 14/8, whatever that ends up being. Okay, so let's plot this thing, this whole range where this exists. Okay, so when my deviation, my Y value is 0, I got 8, and x is 8 7/8. My Y value is 0, is my x-intercept. So at 8, and it's like right there, I guess. Okay, and then at 5, it's 3 7/8. So it's like right there, ish. Okay, and then over here, at my max end at 12 3/4, right, it's gonna be like up here again at 3 7/8, right? So this represents the allowed deviation, right, of this absolute value. So if I were to graph it, the average mass of a baseball, and I didn't have any constraints put onto it, it would be something like this. And this shows, hey, when my mass of my baseball is 0, right, it's deviated from the average by 8 7/8. That should make some intuitive sense, right? But it's outside of the allowed domain, the constraint. My constraint for this is saying, hey, this is where my x value can exist in real life, right? Between 3 7/8, or between 5 and 12 3/4 for the ounce of the baseball. This is the deviation from that, right? So the interpret of this whole function is the average mass of a baseball. And the axis of symmetry is determine the deviation from the average max, right? So right here, my axis of symmetry, saying, hey, if I'm anywhere here on the line, this is my deviation from the maximum, from the average, right? So this is the deviation from the average. All right. That was kind of complicated for a pretty simple, concept. All right, hope that makes a little bit of sense.